Okay, the first one, okay, that one, AAS, atomic absorption spectrometer. Okay, this one we normally do analysis to find the heavy trace element and heavy metals. Okay, but this spectrometer you can only analyze one element at one time. Okay, you cannot do multi-element analysis. Okay, so the concept is based on the wavelength, okay, and atomization. We're using heat energy to atomize, then the sensor will catch the signal, okay, using the wavelength. Okay, so that one is atomic absorption spectrometer. Okay, after that, this one is UV, okay, ultraviolet spectrometer. Okay, this one normally we use to analyze nitrate, okay, sulfate, all these things. Nitrate, sorry, not sulfate, nitrate. Okay, phosphorus, something like that. Okay, now the most important thing here is this. This one is a ICP OES. It's one of the latest equipment. Okay, it's very expensive. Okay, we can now most of the labs they already have ICP OES. ICP OES stands for inductive coupled plasma optical emission spectrometer. Okay, now most of the lab now they are using mass spec ICP MS. Okay, so what's the difference between ICP OES and ICP MS? ICP OES, they only can detect the element, okay, not the isotopes. But ICP MS, you can detect up to the isotopes. Okay, let's say you are doing research, then you need to know the isotope concentration. Okay, so you must use ICP MS, cannot use ICP OES. For our purpose, ICP OES, okay. So now, this ICP OES is very simple. We no need to do any sample preparation because it's normally we receive groundwater sample. Groundwater sample normally very clean, okay, or surface water. If surface water, we just do a simple filtration only. Okay, after simple filtration, then we put in all the standards. Okay, then we start operating the machine. Okay, so based on the calibration standard, we know the machine is running well. Okay, so we can start doing analysis. Okay, we have to program all your analysis here. Okay, the concept here, the sample will be injected into a nebulizer inside. Okay, to form a plasma. Okay, he will show you how the plasma will be on. The plasma is what? How many degrees Celsius? Plasma is 10,000 degrees Kelvin. Okay, very hot. You know what is plasma, isn't it?
Yeah.
What is plasma?
Gas, electron.
Another state of matter. Okay, like a solid, liquid, gas, and plasma. Okay, the concept is same. It will atomize. Okay, then it will go into the plasma. Okay, the sample will be atomized. It will go into plasma. Then the detector will detect based on the wavelength. Okay, it will capture all the signal here. Then you will change it into the concentration level. Okay, like for us, we will do up to ppm level, part per million. Okay. Here we use this machine uses three types of gases. One is argon, okay, nitrogen, and compressed air. Okay. So you can see the plasma here. You can take any photos you want to take. The plasma is inside here. You can see, you know. You can go up to 32 elements per can. This is a simultaneously to detect all the elements. Okay. So you want to take photographs? You can take. Any question? This one nearly half a million. but this one normally we use it for water sample. If you want to use for the powder type of sample, you have to digest first with acid, make it into liquid form solution, then only you can introduce into the liquid. Okay, you cannot use powder form. Okay. One element 25 ringgit. All the heavy metal, fixed elements, okay, all we can use. Now all we are using ICP OES. We are no more using AS because AS now, AS we have to do single element. We have another one, that one is AA400, where we can use we can get 4 elements in one go. That's the maximum we can do.
Take 4 elements at once.
Depends on the standard. You have to prepare all the standards. Then do the calibration first, then you can run like that. But this machine is not very difficult to run compared to the XRL. The program is something difficult. Most of it pH meter, where we can measure the pH directly. Okay, you can take a photo there. Okay, all the pH meters, small equipment there.
The small equipment over there she pointed is a pH meter.
We cannot use solid samples here, all liquid. Okay? This one is a direct mercury analyzer, specially dedicated from mercury. Okay? Direct. You can use solid or liquid. Okay?
Solid and liquid only.
The analysis method we are following APHA method. APHA, American Public Health Association method. Okay. Okay, these are the pH meters where we measure the pH. Okay. pH fluoride, you can use this pH meter, and ISE electrode.
pH meter.
And take photos here. This one is prepared. We always buy from the company. Okay. The chemical compound they won't let us know. It's a secret recipe. Okay. This one we can prepare. There's no business.
跟他讲，那谁要水放在这边量啊？那 pH 呢？是他们买来的，不是自己做的。看，你看，
Use for the calibration.
那只棍里面有颜色。
So normally when you want to do any analysis using instrument, you have to calibrate the instrument first. Without calibration, you cannot run the instrument. What do you mean by calibration? Calibration means, let's say your sample, okay, let's say your sample is unknown sample. You don't know what is the concentration inside the sample. Okay, so for example, let's say sodium. So normally what we do, we put in 3 standards, let's say 1, 10 or 20 ppm. So we will have a straight line graph that is called calibration graph. Okay, your sample must be around this range. Okay, let's say when you analyze, the sample concentration is more than the standard, so you have to do dilution. You understand? You bring it into the calibration range, then only you can measure. For example, 1 to 20 is your calibration, right? So let's say you measure the sample. Okay, you got around 30 ppm, for example. 30 ppm is out of your range, right? Your calibration range. So you cannot, because the instrument works at that calibration. Okay, so what you do the dilution. The 30 ppm you do dilution maybe 2 times. Okay, to make it into the range. Okay, then only you can measure. Any question? Akma, Ana, bagi briefing apa-apa? UV.